Alright, welcome back class. It's me, Seb, once again. I'm going to do a little video for the content of today's stuff, Unit 2, Assignment 4, Assessing Validity of Conclusions. So for this category, like this assignment here, we're going to be talking about the classic phrase of correlation does not mean causation. If you haven't heard that before, that's quite alright. I've used it probably way too often, and it's just basically strong correlation doesn't necessarily mean that something caused another thing. I know that's very vague right now, but we are going to go into that. So one of a good correlation that is causation is this right here. You jump in a pool, you're going to get wet, so long as the pool is filled with water, I guess. But yeah. So there's different types of relationships. So there's cause and effect relationship. So change in X produces a change in Y. So for this, the example they have is increasing the height from which you drop an object increases its impact velocity. I enjoy that one because I like physics. If you drop it from higher, it's going to have a greater acceleration as it goes, and boom. So there's a direct correlation there. And they also have similarly increasing the speed of production line increases the number of items produced each day. Yeah, kind of, that makes sense. Then we have the common cause factor. So an external variable causes two variables to change in the exact same way. So for example, suppose that a town finds that its revenue from parking fees at the public beach each summer correlates with the local tomato harvest. Now, those two variables don't seem to be related in any way, but it's just because that there's good weather, there's going to be more people going to the beach, and because of the good weather, their tomatoes are more likely to grow. So that's something you got to watch out for when you're looking for relationships between variables and looking at stats. There's also the reverse cause and effect relationship. So the dependent and independent variables are actually reversed in this case. So suppose the researcher observes a positive linear correlation, which means it goes from bottom left to top right, between the amount of coffee consumed by a group of medical students and their levels of anxiety. So now the researcher theorized that drinking coffee causes nervousness, but it's probably that they're nervous, so they drink coffee. There's also the accidental relationship. So correlation exists without any causal relationship between variables. So the number of females enrolled in college engineering programs and the number of reality shows. Like, there's no connection here whatsoever. But let's just say that on television, both increased for several years. So they have a positive linear correlation, but it wasn't that because there's females in engineering program that they have more reality shows. Then there's the presumed relationship. A correlation does not seem to be accidental, even though no cause and effect relationship or common cause factor is apparent. So suppose you found a correlation between people's level of fitness and the number of adventure movies they watch. Seems like it makes sense that a physically fit person might watch adventure movies, but you can't find a common cause to prove that one. So that's just a presumption you'll have. Now, with my saying at the beginning, correlation does not mean causation, that's this one right here. There's a correlation, but there's no cause to that. So down below we have some examples that you're going to go through. There's the answers at the bottom down here. All you have to do is do a quick little highlight, and you can see it. But I'll read through them. So one of the relationship is the rate of a chemical reaction increases with temperature. So our thermometer, there's mercury in it, and as the temperature gets hotter outside, it seems like the little red mercury goes up in the tube. And then there's the leadership ability, has a positive correlation. There's prices of butter and motorcycles, interesting. Sales of cellular phones and strong negative correlation with ozone layers. This means that with the sale of cell phones, there's a decrease in the ozone levels. Like, it's a strong negative. The ozone levels are dropping in the atmosphere, as we know, because we are experiencing global warming. And then traffic congestion has a strong correlation with the number of urban expressways. So just asking you to look at these relationships and determine what kind they are. So cause and effect, presumed, common factor, and explain why. And then the next part of this is just talking about finding websites and then thinking about the website. So 5 criteria to judge website content. Is it accurate? Who's the author? Does the website present a biased opinion at all? Is the information comprehensive? And is the website up to date? You don't want to find a website and like, oh, it's from, I don't know, the 2000 at this point. We're in 2019, so you kind of want it to be more relevant. And the following article describes another method of evaluating internet resources. Definitely take a look at that, see what you can find. And then your assignment is down here, which it will look like this. So you're going to go through this and you're going to submit it to the Dropbox. If you have any questions about the content for this one, I know there's quite a bit and it can be kind of confusing. Just feel free to email myself or Chris or come into the class. So I'll be here weekly. So that's all for this video.